You know that a vector represents a displacement. So in this case, the vector is the displacement over by 2, up by 3. But you can use a displacement to describe a lot of different things. So I want to show you kind of a couple of different uses for vectors. So one purpose could be to describe the displacement between two different objects. So like, where am I relative to something that I care about? I'm pretty sure that that is a pot of gold. A very common use of vectors is to describe my displacement from the origin of a coordinate system. And if you think about what displacement from the origin is really describing, it's really describing my position. It's describing my overall coordinates in the coordinate space. So if you imagine that your vector has its tail end, so not the end with the arrow, but the tail end at 0, 0, then the displacement from 0, 0 is the same as telling you what your coordinates are. And in physics, that is called a position vector. Or a displacement could describe the difference in my position at two different times. And in that case, it's described as a velocity vector because it's describing the direction I'm moving in and also the speed I'm moving at. So in the case of a velocity vector, we're imagining not just that it represents this distance, but we're imagining it's this distance divided by whatever unit of time it takes to cover that distance. So one more time, a position vector always starts at the origin and represents my displacement from the origin, and that's my position. And then a velocity vector would represent my displacement from the current time to a future time, and so that's why it represents motion, or my velocity. If you want to actually figure out how fast I'm going, the answer is whatever this distance is divided by time. So I hope you remember from the last video how you notate distance. Think about it for a second. So it's with magnitude. So I'm saying the magnitude of my velocity vector divided by whatever time interval it is. So let's say it's 1 second. So this is going to give me a distance, and that's per time. So it's going to be, whatever number of meters per second. Notice that in some sense, velocity vectors feel a little bit more natural for some applications if you write them in polar form. So I went ahead and I converted this rectangular form into an approximate polar form. And now you can read the speed directly off the polar form because you know that that is already the magnitude of the vector. That's the distance. So my speed would just be this divided by whatever time it happened in. And then I'm traveling at an angle of 10.1 degrees above the horizontal. So for a velocity, I think it makes a lot of sense to say I'm traveling in that direction at this speed, rather than saying I'm traveling like this much over and this much up, which seems a little bit strange unless you have a specific reason for expressing it that way.